Welcome to the Vision Brick. In this video, I'll show you how to detect small objects with SAHI. And before starting, I want to quickly show you what I'm going to do in this video. First, I will talk about why small object detection is harder and how SAHI is successful. And then I will talk about these two approaches proposed in paper, slicing-aided inference and slicing-aided fine-tuning. And I will show you how you can install SAHI. Yeah, this is the first approach, slicing-aided inference. By the way, you don't have to stick with YOLO. You can use any other object detection model because SAHI is not a model, it's just a different approach. So you can use FastRCNN, SST, or any other object detection model. It doesn't matter. Yeah, this example is great. We can check this. Yeah, this is normal YOLO V8 pre-trained model. You see detected 3 objects, and when we combine the same model with SAHI, you see detected 8 objects. And second part is slicing-aided fine-tuning. I'll use Wizardrone 19 detection dataset for fine-tuning because they performed benchmarks on this dataset in paper, so I will stick with that. Here you can see some example images. You see most of the objects are small objects. For example, you can see the cars. And we will train a model. Let me show you that. Yes, you can see the training process here. And in the end, I will test this fine-tuned model on estimates. As I said before, there are two different proposed approaches in paper, and I will start with first one, slicing-aided inference. But before that, I want to quickly explain you how SAHI works. I will use this chart. This is the original image, and we are slicing image into the paths. You see right now we have 9 paths, but of course this value depends on some parameters like x and y. For example, if you decrease the value of the x and y, there will be more paths. But let's say we have 9 paths. So we take paths one by one and process each of them separately. You see this is the patch number 1. And we are resizing it to a larger resolution while preserving the aspect ratio. You see here, this is the resized version of patch number 1. And we are running object detection model on this resized version of patch number 1. You see here, it can be any object detection model, it's up to you. And we do this process each patch one by one. For example, next one will be patch number 2, resize it to larger resolution, run object detection model. And we do this for 9 patch, and in the end we are combining all the result. You see here, result detected objects on full image. So we basically merge the results and we have like detected objects on full image. So this is how SAHI works basically. But if you want to learn more about SAHI, you can read the paper. I think I shared the link somewhere. Yes, here. Okay, let me show you the paper. Yeah, this is like 5 pages. It's not that long. You can read this. There are some UC charts here. Oops. So you can read this. It's up to you. But I will share a link to this article in the comment section. You can read these paragraphs as well. This, for example, what happens is if objects falls between 2 paths. So I explained this kind of situations. You can read this. So we can start, but before starting the first part, there's one more section, installation. I strongly recommend you to create GPU supported PyTorch environment. I have an article, you can read it. You see here. Yeah, it's not that hard, but if you don't want to spend time on creating GPU supported PyTorch environment, you can use Kaggle or Google Colab. It's up to you. So after creating GPU supported PyTorch environment, you need to install SAHI. You can directly install it pip install SAHI. By the way, I followed this GitHub repository of SAHI for installation. Let me show you that. Where is that? Yes, here, like this is basic installation, pip install SAHI, and you see like PyTorch with CUDA support. Yeah, if you want to use, for example, YOLO models, you can install Ultralytics as well. So I did that. And yes, we can start on first part. Okay, now it's time for slicing aided inference. I will directly copy this code and explain you everything. By the way, I already cloned SAHI repository here. You can see the folder and created notebook inside this folder. You see this YouTube notebook and you can see my environment here. So we are loading the model using Ultralytics detection model class. Let me show you that. You can find this file inside this SAHI folder, and there's one more folder named models. And you can see there are different files for different models. Since I'm using YOLO models, I will check this ultralytics.py file, this one. And you can see the class here. Detection model for ultralytics YOLO models supports both pytorch and onyx models. And you see here, I'm using YOLO V8 nano model, this pre-trained model. And you can change this confidence threshold values. And if you don't have GPU supported pytorch environment, you can set this CPU. But I have GPU supported environment, so this is CUDA. And for inference, we are using getSlide prediction function. Let me show you that. And you can find this predict.py file under this SAHI folder. You see one SAHI here, predict.py here, and this is the function. You see there are a lot of parameters, and documentation is great. You can read this. I strongly recommend you to check this file. You see like image, height, width, and this is our test image. This is under this image folder here, cars. Yeah, there are a lot of small objects you can see, so we will try to detect these. And there's slice height and width, and I explained you these parameters inside this chart. Where is that? Here you see x and y. And there's few more parameters that I'll use: overlap height ratio and width ratio. You can find this on blog post as well. Here you see this is about overlap, like 25%. But here you see like 20%. You can change this. This is not like perfect value. You can completely change this. It doesn't matter. So let me run this. Okay, perform prediction on 60 slices. So depending on these parameters, the number of slices will change. Okay. So the next step is, let me show you. Yes, for visualization, you have two options. You can look through this result variable, this one. You can access bounding box coordinates, label, and scores. Let me print labels. You see, and you can use OpenCV for drawing rectangle and other things. But you don't have to deal with this. You can directly use this line. And this is the directory of exports. You can change this. But let me run this. Okay, inside this runs predictions folder. Runs predictions here. Yeah, first let me delete this, because these are old files, I think. Let me run this again. Yeah, here. Yeah, you see the detections here. So this functions works like this. You see the detections, and we can test it with other images. For example, here, yeah, we have this one I used in blog post as well. Okay, we need to change this path. Okay, oops. Okay, here, yeah, you see, yeah, we cannot see clearly, but you can see these cars are really small, and they are detected. So this is great. Okay, there's another function. This one, let me copy. So now I'll use this slice image function, and let me show you that. You see, this is again inside slicing.py file. Let me show you that here. Where are you? Yes, here, you see. So this is great for visualization. It says sliced image, so you can observe this sliced image, and it saves under this directory. You can change this. First, let me delete this folder. Okay, so we have test image here. We can use this image here. Oops, my bad. Okay, let me add this. Yeah, you can again change these parameters, but let me run this. Okay, so you see these are all sliced images. So object detection model performs on this image one by one. Yes, for example, here you see the cars. Yeah, you can play with this, parameters. For example, let me delete this folder, and for example, increase these values. Okay, Yeah, you see there's like less pets, and this is what we expect. You see these are larger pets. Yeah, I think this is a great function for understanding. And yeah, that's it for this part. Okay, now it's time for the slicing aided fine-tuning parts. As I said before, I will use Visdron 19 detection datasets. You can see some examples, and you can see image size distribution. By the way, I will only use these images 2000 to 1500 because I don't have powerful GPU and I don't want to spend so many time on it. So I will only stick with these images, but of course you can train with full set. And there's one important point. The format of the Visdron 19 detection dataset is not in COCO format, and in order to slice these images in SAHI, our datasets must be in COCO format. So if you have dataset in different format, you have to convert it to COCO format, and for example, in Visdron 19 detection dataset, format is different. Actually, let me show you how you can find this dataset. Just copy this, and yeah, you see there's one GitHub page, so you can download from here. I already did that, and let me show you that. Here, image, you see different resolutions. Let me show you. Yes, you see. Okay, and let me show you few annotations. Yeah, this is not in COCO format, you see. So in order to, slice with SAHI, we have to convert our dataset into COCO format. But of course, if you don't want to spend time on it, you can directly download the dataset in COCO format and slice it and fine tune. It's up to you. But let's say you want to use Visdron 19 detection dataset. So I have separate notebook for it. I will only, explain you what happened. You can pause the video and copy the code. So here you see I created a new folder, and this is my Visdron 2019 dataset. And you can see the notebook here. Yeah, I import few libraries. These are paths, and these are classes. You see people, bicycle, car. And you see target width 2000 and target height 1500. I will only use these images. Yeah, this is basically the COCO format you see here. So it basically, we will read annotations from these files and convert it to COCO formats. Where was that? Yes, here. Yeah, this function basically does all the thing. Yeah, for different format, you have to, change the code. And here, yes, this part is important, and I can show you this slice COCO function from blog post as well. Okay, you see here. In SAHI, there's a function called slice COCO. This function takes a dataset that's in COCO format, slice the image, and then creates a dataset in COCO format. So you see there's few parameters like COCO annotation file paths, image directory, these are inputs. And for output, you can change these names. It's up to you. Slice output directory. And these parameters are important. I set slice height and width to 640 to 640, but you can change this. And let me show you the output. Yes, I run this function, and you see sliced image saved to this directory. Let me show you that. Where's that? Slice dataset. Okay. Yeah, you see the image here. All of them are in same resolution, 640 to 640, like expected, because where is that? Let me show you that. Because we set it here, you see. Actually, let me show you this in File Explorer for you to understand it better. Where is that? Here. Yeah, you see our image. You can see the resolutions from middle right. And in the end, there has to be one annotation file. Yes, this one. Let me show you that as well. Let me go to beginning. Yes, you see the height and width. What's height and width? 640 to 640. And here you can see the annotation information like detection, like bounding box, image ID. So we can continue. Let me close this. And yeah, you can see the output. Now I can close this dataset notebook. So I have one more notebook for training. And now we need to convert this Coco format to YOLO format because I will train YOLO model and I will use ultralytics. So our dataset must be in YOLO format, not Coco. But it's easy to do because there's predefined functions. First, we need to import some libraries. You see here, we will use this one for converting. I think, if I'm not wrong. Let me check that. Where are you? Yeah, you see here. Yes. For splitting, for converting. No. We will do it like other one. Sorry, my bad. Let me start from beginning. We import few libraries. You see these are input paths. You see here slice datasets. This one I just showed you in File Explorer. And you can see the JSON file. I showed you that as well. And you see these will be our training JSON file and validation JSON file that contains annotation file information. And this will be our YOLO output directory. So you see this one. We will use this, the JSON file that I showed you, for splitting because we need to have like training set and validation set. And you can there's predefined function. You can directly use that. Coco.split Coco as train and val. So you can change this ratio. And you see here we have train and validation datasets. You can see the output here, train JSON saved. Actually that one, let me show you. Yes, this one, train JSON. We can change the format. Ugly. Yeah, it will take some time to process it, but we can continue. It's same for validation annotation file. So we will use this too. Yes, this step is important. As I said before, I will train a YOLO model and I need to convert Coco format to YOLO format. You can pause the video and copy the code. I didn't add these to blog post because I think this is irrelevant. You know, this is not our topic, the conversion of dataset formats. But you see here, you can copy these codes. Okay, now we have a dataset in YOLO format. Let me show you that. Oops. Yes, you see YOLO dataset here. And we have train and validation folder, image and annotations. Yeah, you see the image. These are sliced images, and you can see the annotation files here. You can see IDs and coordinates. Let me close this. Yeah, it's same for validation, by the way. Nothing changed. Again, image and annotation files in YOLO format. Oops, where are you? Yes. Yeah, you need to create a YAML file for that contains dataset information. I already did that. Let me show you that. You can create it manually, but you can use code as well. It's up to you. So it basically contains path to the training and validation sets, number of classes and names. Depending on your dataset, you have to change these values. Okay, now it's time for training. I will use YOLO 11 nano pre-trained model. And here you see the path to the YAML file, and we are using ultralytics for training. Again, you can change these values depending on your GPU. You can increase page size or decrease page size, and you see the image size here, 640. You can change epoch number as well. So I already trained my model. You can see the output here. Yeah, I didn't train that much because, as I said before, like my GPU is old and I don't want to spend time on it. You know, you can train more with different configurations. Now, the output of training is under this runs folder. You see here, there's one more subfolder named train. Yeah, you can see results, some examples from training. And here we have two models, best.pt and last.pt. You can use one of them. After training is finished, you will have two different model files as well. You can use any of these. So let me check if I missed something. Yes, same thing, you know, training. You can see. Now it's time for testing our trained model. So you see the path here. Same with this one, best.pt here. And first we need to initialize SAHI detection model with our trained YOLO 11 model. This path is, here. You can change threshold. And you see here model type is ultralytics. If you have different model, you have to change this. You see the auto detection model class here. Model type like ultralytics, Hugging Face, torch vision. So let me close this. Yeah, for inference, you can again use get slice prediction function. Yeah, I showed you this before. We have test image, detection model. In this case, this one that I just showed you here, this one, our fine-tuned model. And slice height, slice width. So remember, we will like perform inference on full image. Like we will slice it to 640 to 640 images, and we will run our model on each of these sliced images. That's what we are trying to do from beginning. You see here, you can change these parameters, and you can use export visuals to save the prediction. Yeah, this code does the same thing. Oops, this is my output, for example. You can test it with any image that you want, and for outputs, you see here prediction visual.png. Yeah, you see, let me choose image from here. Yeah, this is not good practice, I know. We can't choose we can't choose image for testing from training set, but it's not the problem here. I just want to show you how you can run inference. So you see here, where is that? Yeah, let me copy this actually. Oops. Okay, let's say I want to test my new model, fine-tuned model. I copy this, and for test image, for example, this one, performing prediction on 12 slice, and let me save the results. Okay, under predictions folder. Yeah, you see, perfect. So let me check. Yes, I think that's it